In this video, we will see the concept of transform coding. Transform coding is used in many of the image compression standards today, and we will see a block diagram of the transform coding process. The transform coding can also be implemented as block transform coding, and we will see the process of block transform coding in this video. Assume that you have an image of size m by n, where you have m rows and n columns. So you have m rows and n columns. First, what we will do is we'll construct an n by n sub images, which means that I will divide this entire image into several sub images of size small n by small n. So if you take a sub image, then the size of that sub image will be n by n. The reason for dividing the entire image into sub images is that we will have to extract minute information from each of the sub images rather than taking the entire image as such. So once you construct an n by n sub images, we will do the forward transform for each of the sub images. So the forward transform can be any of the transforms that we have seen already, such as it can be DCT, the discrete cosine transform, or it can be DFT, or it can be Hadamard transform, etc. So we will be finding the transform of each of the n by n sub images. Then after finding the transform, we will do the quantization process. The quantization process is used to reduce the minute details from the transform coefficients. Suppose that after finding the forward transform, you got a value, let's say one coefficient is 3.5, then I will be truncating that value into, let's say, 3. So we are actually omitting the information that can be extracted from a value of 0.5. We are not taking that, we are neglecting that, we are mainly focusing on the main value or the highest value. So by doing this, we are actually removing the minute details from my image. After the quantization process, the symbols are encoded by using any of the symbol encoding methods such as Huffman coding, and after that we will get a compressed image. So once the compressed image is with you, in order to view that image or in order to process that image, you will have to decompress it. In order to decompress the image, the compressed image is given to the decoder. In the decoder section, we have a symbol decoder first, that is the inverse of the symbol encoder such as Huffman coding. Then we will be doing the inverse transform. So whatever you have done for the forward transform, you will be doing the reverse of that one in this section. So if you had performed the DCT first, then you will be using inverse DCT, and if we use DFT for the forward transform, we will be finding IDFT in this section. Now after getting the inverse transform of the all n by n sub images, then we will have to merge all the n by n sub images to get the decompressed image. So when you compare these two blocks, we have 4 different sections on the compression process, but we have only 3 different sections on the decompression process. The part that missing is the inverse of the quantizer. We cannot have an inverse operation for the quantizer because we will be truncating a value 3.4 to 3, we will be truncating the value 3.9 to 3. So by just getting the value 3, we will not be able to say from what value this 3, it can be from 3.1, it can be from 3.2, etc. So we are actually neglecting the minute details from the image. So that is how we can achieve quite a good compression ratio for the transform coding. So we will have a decompressed image. As a side note, if you have an image of size m by n, and if you are making the sub images of size small n by small n or n square, then this is the number of sub images. Okay, mn by. In the JPEG compression algorithm, we will be using DCT as the transform. So I have given an example for a image that is compressed using JPEG. So this is the original image and this is the uh, compression used using JPEG standard or by using DCT. So JPEG actually employs a block transform scheme for compressing the image. When you compare these two images, you can see that the first image, I'm calling this one as the first image, this is the second image. The first image contains a lot of minute details compared to the second image. So in this image of the bird, if you look at this part of near the neck in the first image, that is kind of blurred in the second image. Similarly, if you look at the tree branch on which the bird is sitting, you can see a lot of changes and variations on the tree branch, but it is somewhat blurred in the second image. So by making the compression using transform coding or block transform coding, due to the process of quantization, we are missing a lot of minute details which are not actually required for the user to perceive. So if we can compromise on these sort of information losses or minute information losses for my image, then we'll be using the block transform coding or the lossy compression such as JPEG. I hope the idea is clear. Thank you.